In this tutorial, we are going to talk about solution concentration. First, we will just define concentration and talk about it qualitatively. Then we are actually going to do some quantitative descriptions by talking about how we can express the concentration of a solution numerically. And then last, we're going to talk about how you can make a molar solution. All right, let's talk about what concentration of a solution means. So if you remember, solutions are made of two parts. There's the solute, the thing that gets dissolved, and the solvent, the thing that does the dissolving. And together, that makes up your solution. So a solution's concentration can be defined as a measurement of the amount of solute dissolved in a certain amount of solvent, or the amount of solute dissolved in a particular amount of total solution. So right here I have a solution or a picture of a solution, and let's say that solution's total volume is 5 liters. And we know that there are 2 moles of solute in that 5 liters. So we could express the solution's concentration as 2 moles of solute for every 5 liters of solution, or if of course we reduce that or we work out the math, you could say that's 0.5 moles of solute per liter of solution. So what that tells me is if I pour out a liter of that solution into another flask, then I should have about 0.5 moles of solute floating around in there. So that's a way of expressing the concentration of a solution. We can express or talk about the concentration of a solution qualitatively. And what I mean by that is we can just say that a solution is either concentrated or dilute. But you need to understand, so we don't put a number to it. We don't say how concentrated or how much solute is in the solvent. We merely just say that it's concentrated or dilute. You have to understand that those are not just qualitative because there's no number associated with them, but also relative. Relative in that concentrated compared to what, or dilute compared to what. So, in generalized terms, if you say something is a concentrated solution, you're really saying that there's a lot of stuff dissolved in it. There's a large amount of solute. Whereas a dilute solution is a solution that has less or a small amount of solute. And you can really only say something is concentrated or dilute in comparison to something else. So here we have 2 solutions. We have 2 solutions A and B. And compared to one another, we can say that one is concentrated and one is dilute. And it looks to me like A is concentrated and B comparatively is dilute because there's less or maybe the same amount of solute but a lot more solvent. That makes it dilute. So let's talk about a few ways, or 2 ways actually, that we can express the concentration of a solution. If you start looking at medications or bottles of solutions like vinegar or ammonia that you would use for cleaning, you're going to start to see that there are concentrations on the bottle. For example, here, this is the kind of vinegar you might buy at the grocery store. You'll notice it says, it's kind of hard to read, but it says 5% acidity. And what that really means is that in this entire bottle, only 5% of the fluid in that bottle is actual acid, and it's acetic acid is the acid that's in vinegar. That means that the other 95% is something else, probably water as your solvent. And so that 5% comes from the volume. So if your volume is 25 fluid ounces, 5% of that, so 5 fluid ounces of that is going to be vinegar or actual acid, and the rest is water. Over here, we have volume expressed in a slightly different way. This is weight volume, 27% weight. WW means weight. So instead of volume, it's 27% by mass. So that's a couple of ways that it can express in a quantitative way the concentration of a solution. And there are two ways that I will need you to know how to express the concentration of a solution. So instead of doing percentages, we're going to do something called molarity, and the second one's called molality, and I'll do that one in a second. Let's talk about molarity first. Molarity, its symbol is a capital M, and the molarity of a solution is a measure of how many moles of solute there would be in a liter of that solution. When you calculate a molarity, the unit on it is going to be moles per liter, or again, you can replace moles per liter by just a capital M. So for example, I can say that I have a 6 molar solution of sodium chloride. And what that tells me is that if I had 1 liter of this solution, that floating around in that 1 liter of solution would be 6 moles of sodium chloride. That's what that tells me. That's what 6 molar or 6M means. All right, so let's do a little sample problem of a calculation you might need to make for molarity. All right, so I've asked what is the molarity of a solution that contains 2 moles of sodium chloride in 250 milliliters of solution. So we know that the formula for molarity to calculate molar concentration is moles of solute divided by liters of solution. And we were given moles of solute right here. So that's our moles of solute. And we were given volume of our solution, but not in liters. We were given milliliters of solution. So we're going to need to convert that to liters before we solve for molarity. So we need to divide 250 milliliters by 1,000 milliliters because there are 1,000 milliliters in a liter to convert this to a liter quantity so that we can then plug it into our equation. And then we know that molarity is going to be your 2 moles of sodium chloride divided by your 0.250 liters. And when you work that out, you get that this solution has a concentration of 8 moles per liter, or 8 capital M. So its molarity is 8 moles per liter. So even though we only have 250 milliliters, we know that if we had 1 liter, there would be 8 moles of sodium chloride floating around in it. Let's do a little bit harder problem. For this one, I want to know how many grams of KOH would be in 500 milliliters of a 0.2 molar solution. So we need to identify what it is we were given. So we were given a volume of our solution. However, it's in milliliters, and our solution volume for our molarity equation has to be in liters. So we're going to want to make sure we convert that to liters, and then we can go ahead and plug that into here. And then we were also given that we have a 0.20 molar solution. That's the concentration of our solution. So that is our molarity, our capital M. So we can go ahead and we're going to take that and we're going to plug that into here. And what it's asking us to find is the number of grams of KOH. The problem is that what we were given is, the volume of the solution and the concentration, and that would solve for moles of solute. So let's go ahead and solve for what we don't know. Since we know this and we know this, let's go ahead and solve for what we don't know and then figure out how we can get from that to what was asked. All right, so I went ahead and plugged in for molarity, our molarity, which is 0.20 moles, and then I converted my 500 milliliters into liters and plugged it in where it says liters of solution. And so I'm going to solve for moles of solute. So our moles of solute is going to end up being, so we got to multiply both sides by 0.500 to get that out of there. And and we end up with 0.10 moles of solute. And again, our solute is KOH. But again, what it asked for in the question was grams of solute, and you have moles. So that should be pretty easy. We can take that 0.10 moles of KOH, and we can convert it to grams by using its molar mass. And its molar mass is 56.105 grams, which gives us an answer of 5.6 grams of KOH that we would find in a 500 milliliter sample of a 0.2 molar solution. Okay, the second way that we would, or that you need to know how to express a solution's concentration is called molality. Molality is symbol is a little m. And I know that it's hard because it's similar to molarity as far as what it looks like, but it's different. To calculate molality, which again its symbol is a little m, you would take the number of moles of your solute and divide it by your kilograms of your solvent. So the two main differences, or the big main difference between molarity and molality, is how you're measuring your solvent. Instead of doing total solution and liters like you would for molarity, you're using mass in kilograms of just the solvent. The units that you would put on a number of, or a concentration expressed as molality would be moles per kilogram, or of course you can just use a little m. So here's an example of a molality question. So in this question, you are given that you have 1.5 moles of C6H12O6, which is just glucose, in 750 grams of water, and it's asking for the molality. So first of all, if we look at our equation, and we start looking at what we were given, we have this already. So we have this. This is the moles of our solute. And then we have grams of water, which we can easily convert to kilograms. And just so you know, there are 1,000 grams in 1 kilogram. And then we can then plug that into there. And what we're asked to find is our molality. So that, of course, is this. That's what we're trying to find. So if we go ahead and plug those numbers in, we get 1.5 moles of our solute per 0.750 kilograms of water. And that would make this a 2 mol solution. And what that really means is that if we had a kilogram of water, that you would find 2 moles of sugar or glucose floating around in it. And I just wanted to really quickly put these two equations up against each other so that you can really see the difference between them, because it can get very confusing considering that molarity and molality are like very similar looking words. They're both abbreviated by M's, one being the capital and one being lowercase. They both involve moles of solute. Where the difference lies, of course, is how we're measuring the volume of the solution. Here we're actually measuring the whole solution in liters for molarity, and for molality, we're only looking at the solvent, or the part that's the solvent on the bottom here, and we're measuring it by mass. So just be really careful and make sure that you read and pay attention to your units and what you're given and what you're asked to find, because it can get very, very tricky if you don't. Okay, and last but not least, let's talk about how you would actually go about making a molar solution. So let's say I asked you to go into the lab and make 500 milliliters of a 0.1 molar sodium chloride solution. So the first thing that you would want to do is you would want to figure out, you know that molarity is going to be equal to moles of solute over liters of solution. And you have all the information that you need right in the question. So you know the volume of your solution is 500 milliliters. So that could go here. You would just have to make sure that you convert it to liters first. And you also know the concentration of your solution already. So that is M, right? You already know that. So what you don't know is how much solute you would need to be able to make your solution. So the first thing you're going to want to do is you're going to want to make some calculations. So we're solving for, in this equation, our moles of solute. So when you do that, when you calculate your moles of sodium chloride, it's going to end up being 0.500, because remember, we got to multiply both sides by 0.500 liters to get that off of this side. And that, of course, is going to be multiplied by 0.10 molar. So we end up needing 0.050 moles of sodium chloride. Well, the molar mass of, so to get from moles to grams, the thing is you can't measure out grams in a lab, or moles in a lab, you have to measure out grams. So you would convert moles to grams of sodium chloride using its molar mass, and that would be about 2.9 grams of sodium chloride. So to make this solution in a lab, you're going to want to get a flask that measures to 500 milliliters, because that's the total volume that you want of your solution. And then you're going to get a scale, and you're going to measure out your 2.9 grams of sodium chloride. And then you're going to take that sodium chloride and you're going to put it in the flask. So you're going to dump it into the flask so that it's down inside the flask, and then you're going to go fill up the rest with water. So you're going to actually pour water until it reaches up to your 500 milliliter mark. So now you've got your 2.9 grams of sodium chloride, and you've filled the solution to 500 milliliters, so you have a total volume of 500 milliliters. And then you would just shake it around and mix it up, and you would end up with a 0.1 molar solution of sodium chloride.